So when you have a system and both of the equations are in standard form, that's the sign that you probably want to solve by elimination. If they're not already both in standard form, then you're probably going to choose elimination because most of your variables have a coefficient. I'm going to work through examples. This is the example of the easy one. It's the easy one because it's already in standard form. And it's the easy one because step number 2 here is already done for me. So step number 1, make sure that the left side, here's the equal signs right here. So the left side has both x's and y's, and the x's and the y's are lined up. You can see that I have an x from the first equation on top. I have an x on the bottom equation, and they're lined up. So my like terms are lined up, my y terms are lined up, my equal signs are lined up, and my constants are lined up. So that's what makes this an easy problem because there was no rearranging to be done. Step number 2 says look for opposite coefficients. And I have opposite coefficients right here. That means I have the same number, but one's a positive and one's a negative. That is opposite coefficients. So this is called an easy problem because I'm not going to have to make them opposite coefficients. They're already done that way. So now all I'm doing is going down here to step number 3. Step number 3 says combine like terms by adding down and solve for the variable. So what do they mean by adding down? They just mean put your x's together. If you don't recognize that that's a 1 coefficient in front of the x term, then put the 1. So 1x plus 1x is going to give you 2x's. You have a positive 2 and a negative 2. That adds to be 0, so you have no more y's. We eliminated the y term. Bring your equal sign down and now combine together your 14 and your 10 to get 24. It says solve for the variable because in this case we have only the x left, so I'm going to divide both sides by 2 in order to get that x by itself, and I'm left with x equals 12. Many students want to stop here, but notice I still have step number 3. It says substitute the answer that you found in step 3. So this is step 3 right here. I found the 12. Substitute it into one of the given equations. So we're going to go back up here to either this 1x plus 2y equals 14 or the 1x minus 2y equals 10, either one of those equations, and we're going to plug and chug. We're going to plug the 12 in, and then we're going to do the math. It doesn't matter. Let me number these equations. This was equation 1. This was equation 2. Doesn't matter which one. I'm going to plug 12 in to whatever you want. Plug 12 into equation 1. So I'm going to plug the 12 in for the x. So that's 12 plus 2y equals 14. Now I've got to solve for y. So subtract 12 from both sides. 2y is equal to 14 minus 12. That's 2. Divide this side by 2. Divide this side by 2. Y is equal to 1. So my answer here, my solution, is the ordered pair 12, 1. Step number 4, which you can't see. Step number 4 says now substitute your ordered pair into both equations, but especially the equation not used in step 4. So in step 4 right here, we plugged it into equation number 1. So now I'm going to plug this into equation number 2. Equation number 2 was the x minus 2y equals 10. So I'm going to plug this in for the x. I'm going to plug this in for the y. So 12 minus 2 times 1, and see if that gives me 10. I'm hoping for a true statement. 12 minus 2 is equal to 10. 12 minus 2, I get 10 is equal to 10. That's a true statement. So I really should, it's a very safe thing to go back now and plug it into equation number 1. Equation number 1 is the equation that said x plus 2y equals 14. So x plus 2y equals 14. The x is 12. The y value is 1. 12 plus 2 times 1 is 2. And 12 plus 2, I get 14 equals 14, which is also a true statement. That means my answer, 12, 1, is indeed the solution to that system. So this is a medium level of difficulty problem. I do not have it in standard form, so I'm going to have to do some rearranging. And then once I get it rearranged, I will not have a pair of opposite coefficients. So I will have to do this multiply part right here. So let's worry about, first of all, by getting, here's our equal sign, and the top problem has the 5x and the y, the 1y on the same side of the equal sign. The constants are on the other. This one, I have y together with my constant, and then I have my 10x over here. The first thing, I don't know, it doesn't really matter what. Do the opposite here to get this constant. I'm going to add 18 to both sides. That's going to get my constant where it belongs, but at the same time that I'm getting the constant where it belongs, my 10x is in the wrong place, so I'm going to subtract 10x from both sides. And that way I can do take care of two problems at once. So now for this problem, and I'm only doing it to that bottom problem, you guys. I'm not doing it to the whole system. I have a negative 10x. I have a positive 7y. Those added to 0, and my 18 was left over there. Okay, so now I've rearranged this. So now I have my system. My system is 5x plus y equals 9, and negative 10x plus 7y is equal to 18. Now, I'm checking for opposite coefficients. I have opposite signs right here, but I do not have the same number. But I recognize that since I have these opposite signs, it might not be too hard to change one of these into the other. For example, if I take this top equation and I multiply everything times 2, then I'm going to get a 10x, a 2y, and an 18. So this equation right here becomes 10x plus 2y equals 18, and this bottom equation is negative 10x plus 7y is equal to 18. Okay, now I have step number 1 and step number 2 taken care of. So now all I have to do is follow step number 3, combine like terms, add vertically. So combine the x's together, those add together to give me 0. 7y and 2y come together to make 9y, and 18 and 18, I believe, make 36. Divide both sides by 9 to finish getting the y by itself, and y comes out to be 4. On step number 4 right here, it says plug this answer back into either one of your equations. I like to go back to one of the original equations, because if I've done some changing, I like to go back to the original equation and plug it in. So I'm going to plug it into equation number 1 right here. Here's equation number 1. It's 5x plus, and then I'm going to put the 4 in for the y. And now I'm just going to combine like terms. 5x plus 4 equals 9. Subtract 4 from both sides. And that leaves me with 5x equal to 5. Divide both sides by 5 to get rid of the coefficient. And x is equal to 1. You do need to check for accuracy by plugging in, here's the point, 1, 4 is what I think my solution is. And I can check those by plugging them into each equations and seeing if I get true. So for equation number 1, 5 times 1 plus 4. Does that equal 9? Yes. 5 times 1 is 5. 5 plus 4, I get 9. So that's a true statement. And then equation number 2, I have 7 times 4. I'm using the original equation, 7y minus 18. That's supposed to equal 10 times 1. 7 times 4 is 28. 28 minus 18. And 10 times 1 is 10, so I end up with 10 equals to 10. That's a true statement, so the point 1,4 is the solution to that system. All right, this example is an example of what would be considered a hard difficulty, and that's because we are given the equation and it's in standard form, so that's nice. We do have opposite signs right here. We have a positive and a negative, but it's a 4 and a 9. And I can't multiply 4 by anything to get a 9. I can't multiply the 9 by anything to get a 4. So In a case like that, it's going to require me to multiply both equations by some multiplier in order to generate a new equation that will have opposite coefficients. Now, the easiest thing to do, what you're actually supposed to do is look for a least common multiple. But you don't have to really worry about that if you just want to multiply by each other. So in other words, this equation that has the 4 in it, multiply it by a 9. The equation that has a 9 in it, multiply it by a 4. And you could do the same thing right here with the x's if you wanted to, except one of these would have to be negative to create a negative x. But anyway, I'm going to distribute the 9. I'm going to distribute the 4, and I'm going to generate a new equation. So 9 times 5, that's 45x. 9 times 4, that's 36y. And then 9 times negative 30, I believe that's negative 270. 4 times 3, that's 12x. 4 times negative 9, that's negative 36y. And then 4 times 18 is 4 times 8 is 32. 4, 5, 6, 7. I think it's negative 72. I'm going to double check my arithmetic real quick because I don't want to make a mistake and have to start all over. So 4 times 18, yes, comes out to be negative 72. Okay, so now I have a positive 36y and a negative 36y. Those are opposite coefficients. So I'm down here now on step number 3, where I combine like terms. I didn't have to do anything for step 1. They were already arranged. Step 2 was multiplying by the 9 and the 4. Step 3 is combining the like terms. So 45x and 12x, that's 57x. That adds to 0. And a negative and a negative are going to combine together to make a bigger negative. So that's 2, that's 14. 7 and 7 is 14, so that's 342. Now I have 57x is equal to negative 342. Divide both sides by 57. Divide by 57. And x is equal to 342 divided by 57. Comes out to be 6. So negative 6. X is negative 6. And we know what to do for step number 4. Step number 4 says to take the negative 6 that we solved right here for the x and plug it into one of the original equations. I always use an original equation. So 5 times negative 6 plus 4y is equal to negative 30. And now solve for y. 5 times 6 is negative 30. Going to add 30 to both sides. Okay, those add to 0. 4y, those add to 0, but I'm going to put the 0 because I need a number on this side of the equal sign. Divide both sides by 4. And 0 divided by 4 is 0. So I think the answer then is negative 60. How do I check my work? You say 5 times negative 6 plus 4 times 0. That's supposed to be negative 30. And 5 times 6 is negative 30. 4 times 0 is 0. So that comes out to be true. Plug it into the other equation. 3 times negative 6 minus 9 times 0. That's supposed to be negative 18. Negative 18. So that equals negative 18 minus 0 equals negative 18. So that's true. So the ordered pair negative 60 is a solution to the system.